continuing with 8-7, we are now on number 3, and we're looking at a natural log. So first off, you still should simplify. Here's the thing. Since there is no addition or subtraction next to the ln, you can divide by 3, which makes your life a little bit easier rather than making it to the third. So I would divide by 3 to both sides to get ln of negative 2r equal to 2. Again, you can do this if there is no addition or subtraction past the natural log or log equation. Makes your life easier. So now that we have a natural log, we're going to rewrite it isolated. We need to rewrite it in exponential form. Remember, the base for a natural log is e. So this is going to become e squared equal to negative 2r, and I need to solve for r. So I'm going to divide by negative 2, and we're going to get r equals e squared divided by negative 2, and we need to put that in our calculator. Once again, to put in your calculator, the e button is second natural log, which will get you e to the. Then you can put in your square. Make sure to get off of your exponents to divide by negative 2, and you should be getting an answer of negative 3.69. Well, that's a negative number. Shoot, does it work? That's the next question. We need to check it. So to check it, once again, we need to check, does it work in our natural log? Our natural log is negative 2 times our r. Our r is negative 3.69. So what's a negative times a negative going to be? It's going to be positive. It's actually going to be about 7.39. So it's positive. Therefore, it has to work. So our answer can be a negative number, but you have to check it, because negative times a negative will get you that positive. So make sure you check extraneous solutions. They're a big deal. All right. Moving on to number 4. Once again, we have a log base 4 of t plus 3 minus log 4 to the 5th equal to 3. That minus means we are doing our quotient rule, meaning that those two things are going to divide. We're going to make this into 1 logarithm of log base 4 of t plus 3 divided by 5 equals 3. Now that we have gotten this into 1 log, we can transform this into an exponential function. So we have a base of 4 to the 3rd equal to t plus 3 divided by 5. I can now solve for t. Well, first off, 4 to the 3rd is 64, and it's still all equal to t plus 3 divided by 5. I need to get t by itself, so I'm going to multiply by 5 to both sides. We're going to get a lovely number of 320 equal to t plus 3. And then last but not least, we subtract 3 from both sides. So t is going to equal 317. As you can see, it only needs to be plugged in to check at t plus 3, so there is no way that this can be negative. So therefore, our t equals 317. If you have any questions on how to solve these, please make sure you contact me in the video chat and or by email. All right. One more example and we are done. Okay. And it's a word problem. I know your guys' favorite, but please follow along. It is so useful. Do you see word problems in their ways of working? So number 5 says the formula of the maximum velocity of a rocket is v equals c ln of r, where c is the velocity of the exhaust in kilometers per second and r is the mass ratio of the rocket. A rocket must reach 7.8 kilometers per second to attain a stable orbit. So it has to be able to go 7.8 kilometers per second, or else it just kind of falls back. So we got to make sure it maintains orbit. Our first lovely question says, we want to find the maximum velocity of a rocket with a mass ratio of about 18 and an exhaust velocity of 2.2 kilometers per second. Can this rocket achieve stable orbit? Well, our first thing is we have to find the maximum velocity. So we know we are looking for V. And then it told us mass ratio, which is R, and our exhaust velocity of 2.2, which is C. So we know this is 2.2 ln of our R of 18. So all you have to do here is just plug and chug. So you're going to put 2.2 times ln of 18 into your calculator, and you're going to get velocity to be 6.36. And again, this is in kilometers per second. So we found our maximum velocity. Now we have to check, can this achieve stable orbit? Did it reach 7.8? It did not. So therefore, even though we know what our maximum velocity is, this is less than 7.8, therefore it never achieved stable orbit. Okay, so make sure you check those. Our last one is, what mass ratio would be needed to achieve a stable orbit for a rocket with an exhaust velocity of 2.5 kilometers per second? Remember, exhaust velocity is your C value. So what we're looking for is R. We have no idea what R is, and we want to maintain a stable orbit. So that means we must reach about 7.8. So that's what our V value is. So we have 7.8 equal to our C value of 2.5 ln of our unknown R. Can you solve for R? Well, it's the same thing. Simplify to 1 log, already done. Get it isolated, so we're going to divide by 2.5 to get 3.12 equal to ln of R, and now can I rewrite it? So again, there is no base of natural log, therefore it is e to the 3.12, and this has to equal R. So plug in e to the 3.12 into your calculator, and you should be getting approximately 22.65. So our mass ratio is approximately 22.65. So see, it does pertain to rockets. So it's actually really kind of cool. All right. This is the end of our 8-7 solving logarithmic equations. If you have any questions, please email me.